Hi, this is Physic in a bit of high school physics, and I'm here to show you the great tracker program which I use regularly at my lessons to motion track videos and analyze motions all around us. This great tool not only allows you to motion track, but also to provide graphs of the movements that are being analyzed. This video was made by my students as part of a classroom assignment, and it is very well made for the purpose. Why? Because you have everything in sight all the time with the camera never moving. You have an inclined plane. Here everything's going to happen. You have the object ready to be thrown. Everything is happening in a more or less unchanging background, well lit, and we have a very important thing. We have a standard for length. This is a 1 meter ruler up here. Let's watch the video. You can see the launching of the cylinder. It rolls up, and you can see it was thrown with just enough force to stop and roll back down. The video contains not only this, it also has the motion of this ring, also rolling up and down, but we will be focusing on the cylinder. So just after we watch the ring, let us just stop the video, rewind, and get to work. To make the most of our motion tracking, we need to make some preparations first. First of all, we need to set up a coordinate system. As all of our motion will be happening along this straight line here, we want the coordinate system to suit that. Here's the coordinate system button. I can then drag the beginning of the coordinate system onto the line we want, then drag and rotate it. This is the x-axis as denoted by a cross mark on the beginning just here, and this has the directions set up. With the axis aligned, now we need to have the right standard for length, and that's why we need the ruler. We go up and we find the calibration tools button. We set a new calibration tape, and we can drag, we can drag the arrows to the 0 mark on the ruler and to the 100 centimeters mark on the ruler, and as you can see, it tells us how many pixels are there between those. We will not want that. We want this to be 1 meter, so we'll just put in 1. Great. Now every distance will be measured in meters, even though Tracker doesn't yet know that. The last thing as preparations go, we need only the part of the video that contains the movement that we are analyzing. So let's just play and pause where the movement begins. We don't want the throwing part, just the rolling part. So we go play and then pause it right here. This is a good one. I'm sure there's no contact between the hand and the cylinder. Yes, here I'm not sure. I think the hand is touching, so this is the launching part. So let's go 1 frame forward, right click on the slider, back down, like so, and set start from frame to slider. Now we watch the whole movement and we want to stop it just as it's ready to fall down of the inclined plane. Okay, maybe 1 or 2 more. Great. Let's just set end frame to slider and we're nearly there. Moreover, we can set the time at the beginning to be 0. It will make our lives easier in the following process. Now we're ready for Tracker to do its magic. To begin tracking, we go to Create, a point mass. It's called Mass A. We can rename it to Cylinder, so we're sure what we're doing. Okay, now I have to Control-Shift-Click the cylinder where it is. Okay, I failed. 2 times the charm. Right. Now we have marked its location on the frame number 0. You can see a circular area, that's the template. Tracker will be looking for this on the next frame. I can enlarge it so that it encompasses not only the cylinder or part of the cylinder, but also some of the surroundings. That's very important. Yeah, that's the right size. Now this rectangular area is the area on the next frame where the program will be looking for the template or something very much like it. You see an auto tracker window. This will do our job for us. I'll put it to the side here so it doesn't interfere with the picture, and let's look at what it offers. I could go search, but I'll just show you search next, and it will search the next frame, and you see it finds the cylinder on the next frame very neatly. The search button would just go and look at the next and next and next frames, but that's in a moment. First, the evolution rate is a setting that allows Tracker to change the template over time because it doesn't look exactly the same. And Automark, well, the higher you set it, the more often Tracker will ask you if it's right in locating the object. So we'll just go search and watch the the cylinder roll. It is actually very important to watch it do its work, because this way you can stop it if it goes completely bonkers. This helps not waste valuable lesson time on a tracking attempt that will actually fail. So now we're just watching it go up and then go down. I will not be cutting down on time. You must see how fast it actually does it all. In the auto tracker window you can see a match score. If this exceeds the auto mark thingy, the mark is automatically accepted. Up here you can see the graph of X versus time being drawn as the cylinder progresses. Let's just wait for it to finish. Just a few frames more. The graph is already nice. And that's it. Auto Tracker's job is done. And in the next video, I'll be showing you how much physics you can get from this simple video analysis. And I'll see you next time. Hoff Physik out.